Hey, what's up guys? So today I'm going to be teaching y'all the differences between a monocot plant and a dicot plant. So obviously they have some very distinct characteristics that make them different from one another. So with a monocot plant, before I continue, sorry, I have my little handy dandy cheat sheet of information and stuff, and then I have some pictures, so when I talk about stuff it will make a little bit more sense to have kind of a visual on certain things I'm talking about. I also talk with my hands quite a bunch, so sorry for that ahead of time. So monocot plants, as the prefix kind of states, mono meaning one, they have one cotyledon, which a cotyledon, I'm going to actually read the definition from my computer here, is a part of the embryo within the seed of a plant. So often when the seed starts to grow, it'll most likely be the first leaves of the seedling that is being germinated. So they use this basis of how many cotyledons a plant has to then classify it into a monocot or a dicot. So obviously mono meaning one cotyledon, biggest difference right there. They also, the veins of a monocot plant, veins on the leaves of the plant are parallel. The vascular bundles, which are the circulatory system of the plant itself, are arranged very complexly. There's really no rhyme or reason to it, but that's how each monocot is arranged, is in that complex sort of arrangement. They have a fibrous root system, which I will then show y'all, and we'll talk a little bit more about in a second. And then the floral parts of a monocot plant are in multiples of 3. So like the petals on a monocot plant will have 3 or 6 or whatever, but they won't have, they won't have 4, or they won't have 4 or 5 or whatever. So always in multiples of 3. So a dicot, as the prefix states as well, you're gonna have 2 cotyledons, and that's also a big distinction between the monocot and the dicot plant. The veins on the leaves of the plant are going to be net-like. So we talked about on a monocot, they're parallel to one another, so all the veins look like, they're right next to each other, don't intercross, don't intersect or anything. And the ones on a dicot plant are netted, so they obviously kind of self-explanatory there. They have a taproot system, which again we'll talk about in a second, which is different from the monocot's fibrous system. And then the floral parts in a dicot plant are in groups of 4s or 5s. So again, more than 3 but less than 6, and then it would be more than 6 but less than 9. Simple math, simple understanding. Don't need to go into too much further detail with that one. So in a we're gonna go into a little bit more depth about what I was talking about just now. So we're gonna start off with the root system. So when I say a fibrous root system, this means that the roots themselves grow in and then they web off into many different directions and occupy the very top level of the soil. So they grow and then they grow out and are all connected and kind of just look like a bundle in the ground, and then they're on the upper level of the soil itself. Taproot, which is the dicot side of the root system, is one main thick root that grows straight down into the soil. So getting a little bit more into depth about that, the taproots, which are dicots, they have one, like I said, one main root that grows straight down into the soil itself. So, and then they have a couple smaller lateral roots that will grow off the main, but nothing not to the extent of the fibrous roots that has a ton. It's a straight main root and then a couple little ones branching off of that. Because they go so deep into the water, not the water, wow, into the soil, they are very good for drought tolerant plants, because they can keep growing and grow and penetrate the earth really deeply so that they can get to the water source. So if they're in a place that doesn't rain a lot, they can still absorb water from really deep within the soil. And they're very good anchoring plants. So a place that might have a lot of wind or a lot of weather like that, they are really good at anchoring the plant down so it won't be ripped up due to extreme weather conditions. The fibrous root system is a group of roots. They are a cluster, but they are similar sizes and lengths. It doesn't go as deep as the taproot, as I mentioned before. And then the primary root doesn't remain whenever it grows like a taproot does. The taproot has the main primary root going down. The fibrous root doesn't have that, it just grows itself. It's really good at holding the soil together because it has many roots branching out and holding on to the soil. With that being said, it's also really good at preventing erosion because it holds all the soil together with all of their roots being clustered and all the amount of roots that they have. So very good at helping prevent erosion. I'm gonna show y'all a picture of that itself. Hopefully y'all can see this, but it's backwards on here, but this is just kind of a basic taproot going down with a couple smaller ones going out, as I mentioned, and then a fibrous root has just several, still around the same size, but several roots compared to just a couple little ones, with the main one being there on the taproot. So that's just a little visual. So like I said, fibrous roots is the monocot side and a taproot is the dicot side. Very telling factor. And real quick, the vascular bundles, as mentioned before, is kind of like the circulatory system of the plant itself. And in a monocot, they're sporadically arranged, but that's how they are in all monocots, so it's kind of their uniform, even though it is sporadic, kind of contradicting, but it makes sense if you think about it. And then in a dicot, they're more like a donut uniform arrangement of the vascular bundles. There's rhyme or reason, they're all in the same spot, very neat, very put together kind of thing. So going into the leaves, so parallel veins are what a monocot has, where they're straight. They parallel lines do not intersect, so they're just one by another. Boom, 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 boom. Don't touch each other, just grow. And then a net-like vein is a dicot, which those will intersect. They'll cross over one another, all that kind of stuff, which it's important for both of them because obviously the leaves is the focus of photosynthesis, which is how plants survive, how they eat, how they grow, all that good stuff. So the veins are an important part. Again, I have a picture here. There we go. So the parallel veins, like I said, do not intersect. They're just straight down. And these netted veins here, they intersect all over the place. So neither one is right or wrong, but that's how another way to differentiate between a monocot and a dicot plant. Talking more about flowers, just again, a monocot plant is going to have parts in threes, so 3, 6, 9, all that kind of stuff. Won't have any less or any more until it'll always go to the next multiple of 3, excuse me. And then dicots will be in 4s or 5s. So again, just a quick little visual, you have these 3 petals here, and those are going to be for a monocot, and then you have 5 petals here, and those are going to be for your dicots. So to talk real quick, again, we're going to talk about more about just the venation of a plant, and this isn't just specific to monocot or dicot plants, but I thought I'd throw it in there too. So whenever you have a parallel or a net-like venation on a leaf, you also have 2 subcategories for both of those. They're both the same, but they are pinnate and palmate. And just real quick, just wanted to throw it in there that a palmate are just small leaflets attached to a common point. So they're gonna go straight up and then they're gonna be even all the way down. They have the one main and then they branch off, you know, kind of like in little V's, kind of the standard stereotypical leaf, if we could so to say. And then a palmate, palmate-venation, excuse me, is going to be exactly like it sounds. It's kind of like the shape of your hand. So they're all attached at a similar point, but they branch off. They are uniform in their own way. And then this picture I was going to show, but it's not really that great. But I did do a little doodle here for y'all. If y'all can see that, a pinnate, like I said, is very just straightforward, very uniform, straight down with the branches out, very even sections. And then a palmate, like I said, looks kind of like your hand. Start from one main point here and branch off as that. So basically that's just the difference between the monocot versus a dicot plant. Just to refresh and just summarize what we went over, a monocot has one cotyledon, parallel veins, sporadically complexly arranged vascular bundles, a fibrous root system, and petals on the flower part in groups of 3s. And then a dicot plant has two cotyledons. The veins are net-like. It has a taproot system. Vascular bundles are very uniform and donut kind of shaped, or like a ring shaped. And then the fuller parts are in groups of 4s or 5s. So hopefully y'all learned something a little bit about the differences between a monocot and a dicot plant. And I know I did, researching all this good stuff. So hopefully y'all learned something, and hopefully I was able to teach y'all something, as this project was supposed to be for. I'm rambling now. But anyways, hopefully this was a good take, and hopefully we all learned something new. And I said talk to y'all later, but probably not. So Merry Christmas, have a good break.